Hi, this is Mrs. Herrera with the Algebra 1 review for actually tomorrow, May 1st. No Google Meets because I'm giving you a chance to get caught up, and also there's a lot of paperwork to do. So here we go. We have recursive and explicit formulas for arithmetic sequences as our topic for the day. And we are given 6 problems to work out, and this is 4.2.5 on Google Classroom. So we're given month N 1, 2, 3, 4, 5, and the balances are 35, 32, 29, 26, and 23. So we're looking for a pattern, and we say what happens. Yes, I do need you to draw the arrows because you're showing the difference between them. So to get from 35 to 32, we're going down 3. 32 minus 3 is 29, minus 3, minus 3. Please make sure you do it for all of the terms in the sequence. So what is that? That's the m, which is the slope. We also call that the common difference when we're talking about sequences. So the first thing they want is a recursive formula, and the recursive formulas are a little bit simpler than the explicit, but they're limited in their use. So f of n is any number term in my sequence is equal to the term prior to that. So that's where we get the f of n minus 1, and then subtract 3. So let's say that I want the third guy in line, the third term in the sequence. So this would be f of 3, would be f of 3 minus 1, which is f of 2. So the second term in the sequence would be 32. And 32 minus 3 would give me 29. And so we see that it does work. Okay, let's go to the next one. I want to do all recursive formulas first, and then go back and do the explicit. The next one is tickets and the cost for those total number of tickets. So we're given 1, 2, 3, 4, 5 tickets, 58, 65, 72, 79, 86. And you're asking yourself, what do I need to do to get between the different terms in the sequence? So if I covered that up, the strategy is you take the second guy in line, subtract the first guy. So 65 minus 58 gives me that 7. So plus 7, it works here, 65 plus 7 plus 7. Since it is the same difference, that is called a common difference. In our linear function, that will become our m, which is our slope. The recursive formula will be f of n is, I look at the guy before me and I add 7. That's what this term right here just means. F of n minus 1 means look at the term prior to myself. The next one, this would be number 6. Number 6 is months 1, 2, 3, 4, 5. 84, 100, 116, 132, 148. And again, if you take the second guy, subtract the first, you get 16. Add 16, which will be my slope, my m, when I write this in the form of a linear function. The recursive formula, you'll see again it's the same. You look at the guy before you, and then you add 16. And that works. Look at the guy before me. If I add 16, that will get me to the 5th term. Okay, this is number 7, and I have 1, 2, 3, 4, 5. This one, the numbers are a little bit larger, but that's okay. You can go ahead and stick that right in a calculator, or you can do it pencil and paper. So if you take the 3, 4, 5, 6, and you subtract the 4, 5, 6, 7, you'll find that the difference is negative 1,111. And again, if you check that, it does hold suit for all of the other members in this sequence, and so you get f of n equals f of n minus 1 subtract 111. Now again, that was number 6 and number 7. Let's go to 8 and 9, and then we will go back and do explicit formulas. This is the number of week and the amount of money you owe. You start off with 125, 100, and so forth. So this is, the numbers are getting smaller and smaller. Más pequeño, más pequeño, más pequeño, and so the difference is 25. Menos 25, menos 25. We're going down by 25. The recursive formula is f of n equals f of n minus 1, which is the guy before me. That's not right. It should say minus 25. Sorry. Getting a little ahead of myself here. I was starting to do the explicit formula. It should say minus 25. Let's make that adjustment. Again, it's the common difference every time, the common difference. Moving on, the very last one. Okay. F of n minus 1, minus 25. Apologize for that. Last one here, the recursive sequence is, it's going up 20, up 20, up 20. And so f of n equals, Alex, could you do something, please, or no? F of n minus 1 plus 20. And that would be the recursive formula. I do want to show you that there is another way of doing this, and that is the explicit formula. And so the explicit formula to me is much more usable. And so the way that we do that is, sorry, my dog's crying. Shy. Okay, the explicit formula is this. We need the slope, which is the minus 3. And we also need the y-intercept, which is our zero term. Now we know this doesn't make sense to have a zero term. It's in theory only, but that is how we're going to get the y-intercept. The y-intercept occurs when x is 0. So from 35, if we go to the right, we're subtracting 3. If I go to the left, I'm adding 3. So having that kind of day here. Okay, and so we have 38 minus 3 is 35. Again, teachers make mistakes too. It's good to check your work. If I add 3, 35 plus 3 is 38. And so that y-intercept becomes my explicit formula. Now you can use this for every single term. You can use this for the 100th term, the 1000th term. I don't have to look at just the one before me. Again, how do we get it? The slope is the common difference, and this number on the end is the y-intercept, which we obtain by looking at the zero term, if it would exist. Going to number 5. Number 5, again, I want the term 0. And what do? Well, going this way, adding 7, adding 7, adding 7, adding 7. So when I go backwards, I am subtracting 7, subtracting 7, subtracting 7. Honestly, I did this right today when we did it in our Google Classroom. You might want to stop in 11 or 12 o'clock. Subtracting 7 would give me 51. Definitely long day. Okay, so then we have 51 plus 7 is 58. And so I get f of n equals 7n, which is my slope, plus 51, which is my y-intercept. Okay, the next one I did right. Number 6, I have 84. I'm adding 16 each time. So backwards, I would be subtracting the 16, which does in fact give me 68. So again, my slope is a common difference. That's where the 16 came from. The 68 would be my zero term in the sequence. And so the y-intercept is 68. 3 more and we're done, guys. I'm trying to get this within 10 minutes. So f of n equals, my slope is negative 1,111 times n. And this number, if I'm adding 11, if I'm subtracting 1,111 this way, I add the 1,100, and this is in fact right. And so that is our y-intercept of 5678. Last 2, and then we're done for today. Looking at the explicit formula again, I'm going down 25 each time. So 125, the opposite of minus is add 25. That would be the y-intercept that goes on the end. So I get the slope, y equals mx plus b. There is another way to do explicit formula, and I'll show you on the bottom, but I really like this one better, and my students tend to like this one better also. So my formula again here is I'm going up by 20. So if I go backwards, I subtract 20, which gives me 40, and my slope is 20. F of n equals 20n plus the y-intercept, which is 40. And again, you could check this on any of them. If I wanted the second term, 20 times 2 is 40. 40 plus 40 would be 80. And in fact, you get this. All right, how do you actually find explicit? Like if you look up explicit formula in a math book, they're going to show you this. It's the first term in the line, and then d is the common difference times n minus 1. Why is it n minus 1? Because you have to go back to that first term. So I don't want to count this term twice, that difference. And so again, I substituted in when the first term is 60, and so the common difference is 20, And so f of n would be 60 plus 20n minus 20. And you see the net is I still get f of n equals 40 plus 20n. Remember, addition is commutative, and so it agrees with this. All right, I'm under 10 minutes. Everybody have a good night. Please check your work and submit. Have a great day.